OpenAI recently introduced a feature called predicted outputs for their GPT-4o and GPT-4o mini models, and it's already proving to be a game changer for efficiency. This innovation is particularly valuable for tasks like AI-assisted coding, content creation, and speeding up workflows. Normally, AI models generate responses one token, a word, or piece of code at a time, which can be time consuming. The predicted outputs feature allows you to specify part of the expected response in advance. This helps the model skip unnecessary steps, reducing the number of tokens it needs to generate and speeding up process. How much faster? According to OpenAI's early tests, tasks like code editing are now 2 to 4 times quicker. For example, editing a large code file or a lengthy document that previously took 70 seconds can now be completed in around 20 seconds. In some cases, this feature more than halves of the time needed to get things done. The concept behind predicted output is simple but powerful. Instead of asking the AI to generate everything from scratch, you provide it with a hint, a prediction of part of the output. For example, if you're tweaking code where most of it remains unchanged except for a few lines, you can input the existing code as a prediction. The model then focuses on filling in the gaps rather than redoing everything. This feature is especially useful in repetitive or predictable tasks. Whether you're updating a blog post, making small edits to a script, or modifying a specific part of a large dataset, predicted outputs save time. By letting the model know what doesn't need changing, it skips unnecessary steps and zeroes in on the updates. Essentially, you're giving the AI a shortcut, allowing it to work faster and more efficiently while delivering precisely what you need. Here's an important distinction about predicted outputs. They're not designed for creating brand new, unique content. If there's no baseline or predictable structure, this feature won't add much value. It's most effective when there's something repetitive or partially known for the AI to work from. OpenAI tested this feature across multiple programming languages, including Python, JavaScript, Go, and C++, and found it effective in each. For developers working in these languages, this can be a major time saver. However, it's worth noting that predicted output is exclusive to GPT-4o and GPT-4o mini models. There's also a few limitations. It doesn't support advanced API parameters like multiple outputs, function calls, or log probabilities. To get the best results, it's recommended for controlled, predictable tasks. Here's an example. Imagine if you're refactoring code in TypeScript, you may have a user class with a username property that needs to be renamed to email. Instead of rewriting the entire class, you can feed existing code to GPT-4o as the predicted output and ask it to make the change. The model will update just the required line while leaving the rest untouched. When the model processes a prediction, it tracks how many tokens it accepts versus rejects. Matching tokens are processed quickly, enabling faster responses while focusing only on necessary changes. This efficiency makes it a powerful tool for tasks where precision and speed are critical. Here's another key detail about predicted outputs. Rejected tokens. The ones the model doesn't use are discarded but it's still built at the standard rate. This means accuracy in your predictions is crucial. A correct prediction can save time and potentially reduce token usage, but a poor one might increase costs without adding value. To further speed up things up, OpenAI has introduced support for streaming with this feature. With streaming, responses are sent in real time, chunk by chunk as they are generated. This means you don't have to wait for the entire output to load. You can process or display parts of it in the fly, reducing delays. Another advantage is flexibility in prediction placement. It doesn't matter whether your predicted text is at the beginning, middle, or end of the response. The model integrates it seamlessly, speeding up process. For example, if you're setting a simple JavaScript server using a library like Hano and need to add a new route, you can provide the existing server structure as your prediction. The model can then focus solely on adding the new Hello World route without reanalyzing the rest of the file. However, predicted outputs comes with some limitations. Certain API settings like max tokens aren't compatible. Features like generating audio, mixing modalities, or function calls also aren't supported. Another consideration is token billing. If your prediction contains 100 tokens but the model rejects 20, you'll still be charged for the full 100 tokens. This makes the feature great for saving time but not always for reducing costs unless predictions are used strategically. For developers, this trade-off means balancing speed and cost efficiency while leveraging the feature where it truly excels: predictable, repetitive tasks. The OpenAI documentation provides in-depth details about how to implement the predicted outputs feature, but here's a simplified breakdown of how you can use it with OpenAI's SDKs. Let's say you're working with JavaScript and need for refactor a TypeScript class. You'd start by feeding your existing code snippet as a prediction parameter. Then, using a chat completion prompt, you'd specify the specific changes you want, like replacing a username property with email. The model, leveraging the prediction you've provided, focuses solely on updating that one line rather than reanalyzing or rewriting the entire class. This targeted approach drastically reduces the processing time and makes the task more efficient. From a practical standpoint, predicted outputs has a broad range of applications, particularly for tasks involving repetition or structured updates. For example, bloggers frequently updating old posts can use this feature to preserve unchanged section while allowing the AI to focus on updating specific parts. Developers making small tweaks in large code bases, such as renaming variables, modifying methods, or adding functionality, can also benefit greatly. Similarly, data scientists working on refining datasets or making small-scale adjustments within large data structures can streamline their workflows with this feature. A practical example might involve a blog post where only a few entries needs minor edits. Instead of asking the AI to regenerate the entire post, you can pre-fill the parts that don't need changes and let the AI handle the specific updates. This not only saves time but also ensures consistency across your work. The key to unlocking the potential of predicted outputs lies in its predictability. The more structured and repetitive the task, the better the feature performs. However, OpenAI emphasizes the importance of starting small. Begin by testing this feature with controlled, repeatable tasks to understand its capabilities and limitations. This approach allows you to assess how much time you can save and how effectively the feature fits into your workflow. It also helps minimize its cost since the model charges for all tokens in your prediction, including those it ultimately rejects. By starting with simpler predictions, you can reduce the risk of incurring charges from inaccurate or overly complex predictions. For developers and content creators, starting small with predicted outputs is key. Begin by identifying routine tasks like updating reports, refining datasets, or modifying boilerplate code. Test it on simpler tasks to understand its behavior before scaling up to larger projects where it can save significant time. This feature excels in structured, predictable tasks but isn't ideal for creating entirely new content without a clear baseline. It also has limitations such as lacking support for advanced API parameters like max tokens and features like audio generation or function calls. Ensure your tasks align with its strengths before relying on it fully. Streaming mode adds another advantage by delivering responses in real time, reducing delays. For example, while refactoring JavaScript, you can stream updates incrementally, speeding up the process. Predicted outputs combines precision and speed for repetitive tasks, and the more you use it, the better you can integrate it into your workflow. Would this fit into your process? Share your thoughts and stay tuned for more AI insights.